And to get to D2L, if you go to the main Normandale page, there's a D2L tab up at the top. And that takes you to a login screen. And hopefully all or most of you know your star ID and your password. If you don't know that, I can show you where IT is and they can get that stuff straightened out for you. But sign in. And you'll see a list of any classes you're taking down here at the bottom. So these are the 2 classes I'm teaching and one sort of related one. This is College Physics 1110. So click on that and that'll take you to the D2L page for this class. And the first thing you see is the main page. Whenever I give a new assignment or put something new up on here, I'll try to be good about putting a new announcement on there. So if you look at that main page, it'll tell you what's new that you need to look at. And then the materials themselves that we'll use, go to Materials, Content, and there are a few categories in there. One of them is old lecture notes. So these are the lecture notes from fall of last year. And the reason I have these up here is because some people, you know, if you'd like to read ahead or something, there won't be any of the current notes up there because I haven't done the lecture yet. But you can go to these old ones and find pretty close to the same stuff that we're going to talk about. I, changed little things, but it's basically the same. So if you go to like an old PDF, this is the one from August 29th of last year. You can, scroll through and read through that. And I think it should be pretty understandable. But there are also companion videos available. If you go to YouTube and, search Guy O'Lakin or search College Physics fall of 2017, you'll see all of the videos from that semester, and you can look at the old video while you take notes in the margins of the PDF or something. So let me know if you would like any hints for how to use these materials if you're going to be out of town or something and you need to rely on this stuff for a while. I'd be happy to give some suggestions for how to use it. Okay, so we're in the content in D2L. There's the problems and the problem solutions. We're not going to get into that stuff today, but pretty soon. And then what we want right now is in the course information. And there's 2 things there. There's the syllabus. That's what I'm going to go through carefully. Then there's also a document called Campus Support Services. And it just lists, a pretty comprehensive list of all the things that are available that might be useful on campus. Academic support services. There's a tutoring center. It gives the location of that, and I'm going to mention later that a couple of my office hours are going to be done in the tutoring center. So this is the location of the tutoring center and the hours. Makeup testing center, library, disability services. There's just a lot of information there. So if you have the time, you might want to just read through there, see if there's anything there that could be useful to you. Okay, and then the other thing is the syllabus. And so now I'm just going to spend a little time going through the syllabus. I have one syllabus for all 5 of my lab sections, so your information is in here somewhere. I guess this is everybody sitting here right now is in either section 91 or 92. And then it breaks down for your section when your lab is. And it gives the room assignments for all these things. Notice that all the labs are in the same room, and that is going to be possibly useful to you because, and knowing when these other labs are is going to be useful because if you miss your lab or miss one of the lab exams that I'm going to talk about, you can't make it. It's fine with me for you to show up to any other lab in the week, you know. We don't usually have trouble with space or anything. So, like, for example, I guess in the night class, say you're in section 91 and you can't make it to your lab, you know, most people in the night class would just come to the Wednesday one or the Monday one. But if it ever is the case that you can't make it to either of those, but you can make it to one of the day class labs, feel free to go to any of those instead. My name's Dyle Abey, and I do have a PhD, not in physics though, it's in engineering. So what that means to you is, you know, the introductory physics, the early physics stuff for engineering and physics majors is the same, but I just can't answer really questions about like the really interesting like modern physics, you know, like if you have questions about quantum mechanics or what happens if you fly a, you know, part of a proton at the speed of light past the to the next galaxy, and like I can't answer those kind of questions, you know. That stuff is really interesting, but that's not my area. If you have questions like that, well, so I should say my understanding of that kind of stuff is it's sort of like a Scientific American type level, just like hand wavy, you know. But if you ever want to talk to somebody about modern physics type stuff, the kind of stuff that we don't cover in these classes, I'd be happy to point you to some people in the department who do that kind of stuff. My office is upstairs, 2302, just right at the top of the stairs up here. None of my office hours are in my office. I do 2 in the lab and 2 in the tutoring center, or 3 in the lab, 2 in the tutoring center. So you don't probably need to know this, but if you ever want to just try to catch me in my office, that's where it is, upstairs. The best way to get a hold of me is email. I, you know, get notifications whenever an email comes in. So if I can answer your question easily right away, I'll answer right away. If I need more resources to answer your question, like I need to draw something up, yeah, or you know, write equations or whatever in my reply, or if I need to look something up to answer you, then it might be a little longer to get a response. And this is not personal, but sometimes when that happens, I get an email and I think like, okay, I'm going to figure out the answer to this and then email them back. And then in the meantime, this many new emails come in, and then your email is below the screen on my phone, and then I forget about it. So you'd think that probably I should have come up with a better system than that, but I haven't. So if that happens, just send me another email like the next day, like, hi, this is my second email, and then I'll feel bad and I'll probably email you back pretty quickly about it. This is my phone number. I don't have a phone in my office, so you can never call this number and talk to me immediately on the phone, but you can leave a message and then I'll call you back. So sorry about that. Email is the best way. My office hours are Mondays during the day from like 11 to 12 at the tutoring center. And then the ones that are more probably useful to you, in our lab room, I do 2 office hours on Mondays from like 4 to 6. So the 2 hours right before class. And then Tuesday, 11 to noon in the tutoring center. And then Wednesday back at the lab, the hour before this class. So if you can fit it into your schedule, if you can if you, I mean, I know a lot of you come straight from work or whatever, but if you happen to be free an hour or two before either one of the night classes, either one of these classes, um, it seems to be a very useful thing for people who just get in the habit of coming to the lab. There's tables there. You can sit down and work. You don't even have to have any specific questions when you come in. You can just work on problems. And then if you get stuck, there'll usually be other students there working on stuff. So you can talk to them or you can ask me. I'll be sitting there. So it's sort of like a study hall. And for the most part, the students that in the past have gotten into the habit of coming to like one or two of those office hours during the week, like every week, have done better in the class than the class overall, you know, so it seems to be a helpful thing. Okay, any questions about class times or lab times or any of this contact information, office hours? Okay. All right, so now the materials you need for this class. All that you need is a calculator that has sine and cosine. There's no required textbook for this class. I would say if there are any of you that are taking this class because you're going to major in something where you're likely to actually like use this physics, you know, do physics calculations again, or if you're taking this class to get into like a professional school where you're going to have to take some kind of like standardized test, like I guess I'm mostly thinking of the MCAT for anybody who's here because you're applying to medical school. In those two cases, if you're going to have to do physics calculations again in the future, you know, I would recommend getting some kind of reference book. And so I have two good ones written down here. One is an actual textbook. It would be the textbook required for this class if I required a textbook. But for this class alone, you're not going to need another source. And in fact, it has been my experience that you're better off not getting an outside source as far as just like getting ready for the tests and stuff. I mean, I'm doing everything I can to tell you in class exactly what you need to know for the test that I'm going to write, you know what I mean? And so it can get a little more confusing if you get out a textbook where the stuff that I'm going to cover in this class is spread out over 300 pages or something. You know, I mean, it's always helpful to get another perspective on that stuff, but as far as like getting ready to just do the assignments and the tests that I'm going to give you, I'm trying to do that as efficiently as I can. So, but these two reference books, this Giancoli book is is what I would have as a textbook if I had one. And then Sham's outlines, I don't know how many of you have ever seen those before, but Sham's outlines are just the greatest things. They're paperback books with maybe 200 pages on average, something like that. They're designed for people who've already taken a class as sort of like a refresher. So they don't go into a lot of wordy detail in describing the stuff. It's just very concise descriptions. And then they have a lot of problems with solutions, you know, provided for the problems and answers for every single problem, I think. So, and they cost like $15 or something. They're really cheap, you know, whereas this textbook here, even if you got like an old edition of it, you know, you can save a lot of money by getting an older edition, but it's still going to cost you over $100. The Shams outline costs you $15 or $20. And so I love that as a way to get ready for, like I said, the MCATs or something. It just has a lot of problems you can work through. Yeah. And it's not just available like for this class. Basically, every science class you take from now on, there's a Shams outline available for it. I just sort of little by little got into the habit of just getting the Shams outline for every subject I went into at all. I have like little red and yellow paperback things, and my whole basement is just like red and yellow with these things like topics that I never took that I wanted to learn, or things that I wanted to do extra problems on and stuff to learn it better. So yeah, those are great. If you don't have a calculator that has cosine and sine, and you want recommendations on good calculators, you know, one that you'll use in future stuff, or maybe just the cheapest one that'll be good for this class, come talk to me and I can give you some suggestions. The prerequisite for this class, there's only one, and it's college algebra. The funny thing about that prerequisite is we really, almost all the math we do in this class is just regular algebra. That prerequisite of college algebra is mostly kind of an indication of like how comfortable you need to be with regular algebra. It's a mathy class, but it doesn't have a lot of real complicated math. So if you haven't taken college algebra, but you like math, you've always done fairly well at math, that kind of thing. I've had many people take this class who hadn't taken college algebra, so you might want to just come talk to me about it. And after I'm done going through the syllabus, I'm going to give a set of 5 math questions that just give a sort of indication of the kind of math that you'll see in this class, so you can kind of judge like, yeah, this seems like about the right level, or versus like I've never seen that stuff before. The website for this class I showed you already is the D2L website, and you should try to get in the habit of just checking that once a day or whatever, see if there's anything new that I posted. And then next, it just goes into all the different topics that are going to come up in this class. Let's not go into those right now. I'll introduce those, later on. But if you're interested, you can look through this and kind of get a sense of what sort of stuff we're doing. Overall, Physics 1, which this is Physics 1, has to do with kind of the motion of things that you can hold in your hand and see happening and stuff, like what happens if you take a ball with this amount of weight and throw it over here and it hits something else, and, calculations of how everyday objects sort of interact with each other, interact with gravity, that kind of thing. Physics 2, which if anybody here who's taking Physics 2, you would, take in the spring, is mainly related to electricity and magnetism. So sort of goes into the stuff that you can't see and feel as readily. But this is kind of the more intuitive one. Although mathematically, I wouldn't say it's, necessarily like easier or anything. It's just sort of what is easier about it is you kind of have a feel for what's going to happen. In some ways, and I'll talk about this in more detail, in some ways having a feel for what you think is going to happen can kind of hold you back, because there are a lot of cases, and I'll try to be really clear about when those are coming up, where what you think is going to happen and what almost everybody in here thinks would happen if this, you did this, is not what actually happens. And your intuition is actually going to lead you astray. And in those cases, I'm going to try to very carefully point out, like, here's what you probably think, here's what most people think would happen, but that's not what happens, and you need to like actively go into your brain and erase what the wrong stuff you've been thinking of for, your whole life, basically up until this point, and replace it with the right stuff. So Okay, so now grades. The grading scale is 92, 82, 70, 60. That's a little unusual. I mean, like for people who grade on a straight scale, 90, 80, 70, 60 is a lot more common. I bumped up my A's and B's mostly just from experience. That just seems to be like with the way that I do my problems and the way I do my tests and stuff, that just ends up being sort of a better distribution of grades. I don't think you'll find that that's a especially hard grading scale or anything. I think if anything, probably there's more A's and B's in my classes than in other college physics classes, that I know of. But that just kind of reflects the way this class is laid out more than anything, I think. And then the final grade is going to be broken up into 70% of the grade is based on exams, 20% is based on lecture quizzes, 10% is based on lab exams. And so that means that all of your grade, 100% of your grade is based on tests in some way or another, that makes a lot of people sort of nervous. I'll try to explain why I don't think you should be nervous about that, and I'll explain how the problems that I'm going to expect you to work on are going to come into this grading system that doesn't have any homework being turned in, So before I go into details on the different things that make up this class, any questions on prerequisites, topics, the way the grades are broken down? Yeah. Yeah, that's perfect. Yeah. Yes. Any calculator you want to use for tests is fine. Okay, so the problems that I'm going to assign in this class, you're not going to turn them in, but let's see. They're all problems that I've made up, and full solutions are posted for all of them using the approach that I am teaching in class. So for any problem, the solution is right there available. But the exams are going to be questions. Everything on every exam is going to be very similar to the practice problems that I assign. And so you're going to want to do those problems when I assign them. And you're not going to want to, I've had this happen before. I think, okay, so a lot of the people that take this class are in biological sciences or chemistry or something. And the way you study for those kind of classes is pretty different from the way you study for math and physics. And so I've had people who, they're used to studying with, going through the textbook over and over, reading the stuff over and over, and then studying with flashcards and whatever. You're just trying to remember everything that, and they've sort of approached doing these practice problems that same way, there's this many practice problems. I'm just going to go through the solutions and remember the solutions. And that doesn't work. Really, it doesn't work at all in this class. It turns out maybe I would have even thought at the beginning that it might work okay, but it just doesn't. In order to understand these problems, you have to do these problems without looking at the solutions. You're basically trying to get to the point where if someone asked you how to do one of these assigned problems, any one of these assigned problems, you could explain to them, go through it with them. And if they ask questions about why is this negative here, or why is this a square root, you would be able to explain why each one of those steps is made. If you can get to that point on these problems where you can do that without looking at the solutions, explain at every point why you made the decision you made, then you're going to do great on the test. And so I would think of the solutions as like they're mainly to check your work when you finish the problems, or if you get stuck on it, to give yourself like a hint. You can go to the solution and be like, oh, that's what I was missing. One thing that I'm going to do with assigning these problems that maybe is you're not very familiar with is so I'm going to assign these problems. I say assign, like I'm just breaking down all these problems into what I consider to be sort of a doable workload that'll get you through all the problems you need to at the right amount, at the right time. But so I'm going to, so when we do a new topic, I'm going to assign the problems the first time. 2 weeks later, I'm going to assign the even versions of those problems again. 2 weeks after that, I'm going to assign the odd numbers of those problems again. And the idea is just to keep going back and refreshing your memory on these topics. When you see them the second and third times, ideally, the hope is that you can go through it pretty smoothly. You've already done it once, but it's just trying to keep those topics in your head. Okay, so those are the problems. And those problems, let's say, I don't know exactly how many there are, maybe somewhere around 100 probably total problems for the whole semester. And the main, your main job for the semester is understanding those 100 problems, trying to get to the point where you could explain how to do any one of those 100 problems. Okay, but those don't go into the grade. So now are the pieces of this that go into your grade. The first one is the exams. There are 5 exams. They're all worth the same amount. So each exam is worth 14%, which means that, it's not very like super high stakes on any one exam or anything. That's including the final. So the final is only worth 14%. When you get to the final, you will have already had 4 scores, right, on the previous 4 exams. And if you score higher on the final than any one of those first 4 exams, so say your exam scores are 90, 80, 80, 60, how many is that? 90, 80, 60, 90, that's the 4, okay? And then on your final, you get like a 85. Then I'll take the 85 from your final and replace the 60. So your final score, your final exam score is going to be 85. That's what you got on the final. But I'm also going to replace the 60 with the 85. Okay, so it's sort of a way for if you have one exam that goes badly, it doesn't have to affect your grade at all. You do well on the final, you can replace that. But I also use that approach as the only way that I do makeup exams for the most part. If you have something you have to get to or whatever, come talk to me and we'll talk about it. But the idea is, if you miss one of the first 4 exams, then right when that exam's graded, it shows up in your total class score as a 0, and it stays a 0 all the way up until the final. And then whatever you get on the final counts as the final score and replaces the 0 on the other one. So you can miss one exam and your final score is going to replace the 0. If you miss more than one, then that, there's nothing built in to deal with that. So we need to talk about it before you miss a second exam, basically. And here is when the exams are going to be. So I would just look at these dates and make sure that that works with your schedule. If it doesn't work with your schedule for more than one exam, we should talk about it. Again, like the labs, if there's ever a time that you can't make it to your exam, like you're busy Monday, September 17th, but you happen to be able to make things work at your job or whatever and come in the afternoon on Tuesday the 18th, you can do that and there's no problem. You just take the exam with day class and that's easy. By the way, these are not the exact same exam. It's like different versions of the same exam. So I don't know. So if you ever do that and then like are studying with someone else and compare your two exams, they're going to be different. That's just how I do it. Any questions about the exams? Okay. So yeah, I think there's always sort of a feeling out process at the beginning of a semester. Some people are more comfortable with the way one instructor teaches, and some people feel more comfortable another way. And when I give back exam one to people, there's always a couple of people who have worked hard, are studying a lot. They're just not approaching it the way that I picture approaching it, kind of. And if that happens to you, I mean, the good news is, say you get a 1% on exam one. I mean, that never happens. I don't even have that many questions on exams. That's not even possible. But so you get a 1%. You're not happy with that score. But that doesn't have to show up in your grade at all, because if you in the final you get a 90, then 90 replaces the 1. And second, you can just sort of use that as like an indication that the way you approached studying for that first exam wasn't working very well. Bring your exam in to me and we'll talk about what you did, what I would suggest you change, and hopefully turn things around. I've had that happen a lot of times, where somebody who is a good student, works hard, does badly on the first exam, brings it in and talks to me about it, and we come up with sort of a plan, and then they get an A in the class. So this makeup idea means that you don't have to freak out when you get your first exam back, even if it isn't good. Okay, the second part that makes up your grade are lecture quizzes. Oh, I didn't say this, but this is important. These exams, every one of these exams is cumulative. So as you're getting ready for these tests, you need to be regularly going back and reading back over the notes, going back over the problems, which I'm trying to set up a schedule for when to do these problems that makes you do them. You do them, and then you do some of them again, and then you do some of them again. Hopefully that'll help make it all sort of stick over the semester. But yeah, so definitely remember that. Okay, now lecture quizzes. These make up 20% of the grade. These are the dates of the lecture quizzes. And those are just going to happen in the last 15 minutes of class or something. And while the exams are all problem solving, that's actually like doing mathematical calculations, the lecture quizzes are just short answer, remembering stuff that I said in the lectures. So doing well on the lecture quizzes is just really remembering what I said in the class. And the only way to get ready for that is to read the notes and, underline stuff, highlight stuff, try to try to make a mental note of what seem like the most important ideas. And those lecture quizzes are also cumulative. So you're going to need to keep like reading back through the notes or skimming back through the notes sort of multiple times to get ready for those. Each individual quiz is not worth a lot. Like each one is worth about 3% of your grade, but they add up to a big chunk. They add up to 20%. One of those scores is dropped, so you can miss one of those without it affecting your grade. But if you miss, I don't have any system in place to do makeup quizzes, so if you miss a second one, then your possible score for the class just drops down 3% and so on. So you don't, try not to miss those. But the dates that they're going to happen are all given here. It says to notice that they're basically all 2 weeks apart, except for quiz 3 and quiz 4 are just 1 week apart because of I think days that there's no class at Normandale or something. So here's the way I kind of think of, you might sort of think of, at first thought, that sort of seems like expecting you to understand the material in a lot of detail. But here's the way I think about it. Most often in physics classes, you have an assigned textbook, and the part of the textbook that covers this semester it takes up about 300 pages, like a big number of pages. And all of this is sort of loosely assigned as reading work, like read chapter 1 and do these problems or whatever. And that's a lot of reading. And I'm replacing those 300 pages with just the stuff that I say for an hour and a half for 30 classes or something. There's probably fewer than that even. So the amount of text, the amount of material that you're responsible for is way, way less in this class than it is in, other physics classes. So the trade-off for that is I try to boil down what you're responsible for to a very small amount, relatively, and I expect you to read over that stuff more carefully and remember it in better detail. It's like instead of expecting you to read Moby Dick, I'm giving you the Cliff Notes for Moby Dick, but you do have to remember everything in the Cliff Notes. That you will not actually be responsible for Moby Dick at all. That was a metaphor or a simile, possibly. I never understood that. Anybody have any questions about the quizzes? Okay, and then the last part of the grade are the lab exams. The labs that I do, you can think of the labs as largely separate from the class. Like you could do perfectly well on the quizzes and the exams without doing the lab part of this class. And you could pretty much do fine on could do pretty well on the lab exams without taking the class. So labs and the lecture are kind of separate. The labs that I use are designed to try to really help you with your just sort of intuition of what's going to happen. So there's a lot of emphasis on okay, you have a ball spinning around on a string like this, and the string breaks. Where's the ball going to go? someone looking at it from the side, what's its trajectory going to look like? From someone above, what's it going to look like? What's the direction of the acceleration of the ball when it's here? What's the direction of the velocity? That kind of thing. So that's what we're going to focus on in labs. And 3 times during the semester, we're going to just do tests of the stuff that we've done in the lab. So in the labs, you're going to do a bunch of sort of intuition-based problems. And in the lab exams, you're just going to have to answer like very similar, questions that require the same sort of thought process. I am going to take attendance in lab, so you do have to come to lab, but you can miss 2 of them, and it doesn't affect your grade at all. If you miss 3 of them, you can't miss 3, so be careful about that. But really, the more important than attendance in the lab is making sure that you understand the concepts that we're going over, so you could answer similar questions. And like I said before, if you can't make it to your lab, but you can make it to another lab, that's fine with me. You don't even have to tell me ahead of time. Just show up for whichever one works, and we'll check your name off when you come to lab. Okay, and those are the dates of the 3 lab exams. They're not worth a lot. Each lab exam is worth as much as a quiz. If there's one of those lab exams you can't make it to, but you can make it to another lab exam, then just like with the labs, show up, and you don't have to tell me ahead of time to show up and take the lab exam with them. Any questions about labs or lab exams? Okay, and then some stuff about cheating. I don't think that I've ever had a cheating incident in the night class. The day class, I've had some issues with it. Since all of your grade is just different types of tests, cheating basically means I catch someone copying someone else on a test. And if that happens, I'll give a 0 on that test with no chance to make it up. So, it drops your score down 14%. And if it's a exam, and then a note will be put in your Normandale science folder. So future professors can just sort of, it doesn't follow you outside of Normandale, but other professors at Normandale can see if there's sort of a pattern developing or whatever, that, more serious issues. But anyways, just don't copy on tests. That's not my intention. Like I said, I don't think I've ever had that come up in the night class. General policies and comments. I don't take attendance during the lectures. And so if there's ever a day that, you can't make it, or just a day that you're just you're not in the mood, you're not going to be able to concentrate anyways or whatever, don't feel bad about missing class. Just, if you're, I remember when I was in college being in classes where I was just sort of zoned out and taking notes kind of mindlessly. It doesn't really do you any good to sit through a class where you're just doing that. So if your head isn't there or whatever, just skip the class, and then the next day or whatever, when you're ready to be more focused on it, watch the video on YouTube. You can print out the PDF of the notes that I took, take notes in the margins of the PDF, and I think that works better. It also helps sort of keep the energy level in the class higher, because sort of a bummer when like you look out and there's two people sleeping and someone like playing on their phone or whatever. So if you don't want to be there, just don't come and just do the class in your own time when you have a chance to watch the video. All the material that you need will be available on D2L. So like I said, get in the habit of checking D2L regularly, just every day, just, go and see if there's anything new. And then just try to keep in mind that, everybody's been working all day. Everybody has to deal with worse traffic than they were hoping for that night to get here or whatever. So just try to take a deep breath if you start getting riled up in class. People get annoyed with each other or whatever. I know that happens, but just take it easy and we'll get through it, And definitely don't be rude to me. I mean, I'm the teacher. I don't like it. If I have to cancel class, you can check with this number. I mean, if I ever have to cancel class, I'll put something on D2L. So if you check that every day, you'll know. That doesn't happen very often. I am going to cancel class the Wednesday before Thanksgiving. The day before Thanksgiving. So you can count on that now. But if anything else comes up, look on D2L. And here's a little blurb at the bottom about the Office for Students with Disabilities. If you've ever been diagnosed with any kind of, I mean, they cover such a wide range of issues, but with dyslexia or any kind of like learning disability, or even if you haven't been diagnosed and you just feel like the amount of time, like if you just have a history of running out of time on exams or something like that, and you think like, okay, maybe I could just use extra time to take exams or whatever, you should just call them, go visit. They're really helpful, very welcoming, and they can give you accommodations if you meet, if you have any needs like that. If you need like time and a half to do an exam or whatever, then you just go to their office and take the exam in the office and they give you the extra time. Or if you need an extra quiet space to take exams, they do that kind of stuff. I do want to say one thing that I guess I meant to say when I was talking about the exams. Well, I guess it sort of covers the whole grading approach. I know it makes some people, like, people have different levels of comfort taking exams, and it makes some people especially nervous to think that your whole grade is based on tests. Like if you feel like you don't test well, then that's not a very comforting thought to think that your whole grade is going to be based on tests. I do think that there are a couple things that I do that that are going to make you like sort of minimize that test anxiety. The first one is that I think you'll see that the kind of questions I ask on all my tests are very, very similar to the problems that you're doing to get ready for the tests. So you're never going to like look at a test and have like a moment of like, oh my God, like I've never thought of it this way or whatever. It isn't really that way. It's sort of just designed to see that you've worked on the homework questions to the level of detail that I want you to, And then the second thing is I give you tons of time. Unless I make a mistake, which I guess happens sometimes, but you're pretty much always going to have plenty of time to finish the exam. So you're not going to feel like you're racing against the clock to finish. And I know that causes anxiety a lot. I always write the exams with the attention that half of the class, the way I think of it when I write it, is I want half of the class to have already left, to be gone, hand in the test and be gone after an hour. And then, the class is an hour 20, so that means that the other half of the class still has 20 or 25 minutes or whatever to finish. And so, I don't know. I think those two things together, when I've talked to people who were nervous about the format of the grade and stuff, they've told me that they were nervous about the testing thing, but that they felt pretty comfortable once it actually came time for the tests, But if you have concerns about that, come talk to me. Okay, any questions about the syllabus overall or the structure of the class? Okay. Well, the next thing I want to do is I just wanted a little bit about what I think are good reasons for taking this class, and I just want to make sure that if there are people who would be better served in another physics class, that you're in another physics class. So here's what I think would be the 3 reasons to take this class. And like I said, with the with the cheating issues, I don't think this really applies to the night class as much as it does to the day class. Day class tends to be more students just coming out of high school. The night class, tends to be people who kind of have a school plan already in place. But can't hurt, so I'm going to go through it. So the first reason that you would take this class, I think, is that you need it for your major. That's obviously you can't argue with that one. And lumped in with needing it for your major is that you need it to transfer to some kind of graduate or professional school that you're applying for. The second reason is that you're considering a major or a couple of majors where this is a requirement. And the third, and I think let me know if you can think of any other good reasons besides these 3. But as far as I can tell, this is the only other reason you would take this class, is if you have an interest and, or good ability in mathematical classes. Okay. If you are taking this class and none of these 3 things apply, like, for example, maybe some people are taking this to meet like a science requirement for, just to graduate from 4-year college or to get a 2-year degree from Normandale, you need science credits. So maybe you're taking it for that reason. So, and I'm all for that if you tend to be fairly good at the math classes you've taken and or you enjoy the math classes that you've taken. But if you don't have a special interest in mathy type classes and you're just taking this to get a science requirement fulfilled, Normandale has different levels of physics classes. There's kind of 3 different levels. And so you might want to consider taking, so here are the other options. For getting your science requirement. One is called Physics for Future Presidents. And what that means, Physics for Future Presidents, is it just sort of, it's not as much about calculations. It just kind of explains how the physics work of different sort of global, policy type issues, so like they talk about global warming and probably nuclear energy and, that kind of thing. But it's just not as calculation heavy, and there's not as high a math requirement. You don't have to, it doesn't have a prerequisite of college physics. And then the other one is called Observational Astronomy. Both of these just have less math. I think what happens sometimes maybe is like people like look online or whatever and they see like someone's teaching the class and they have reviews that's like, oh, it's like this person doesn't smile when they say hi to you or whatever, and the person just like, I don't want that class, I want this one. But don't take this class if it's not the right class. You know what I mean? That's all I'm trying to get at. And the other thing is, if anybody here is thinking of majoring in any area of engineering, then this class will not give you credit for that. That's happened a couple of times. So engineering majors, and also physics majors, if you're thinking of majoring in physics, should take the calculus-based physics class. Any questions about that? Okay, let's see. The last thing I want to do, why don't we, I want to do this, I'm going to write up 5 math questions, and the idea is just for you to sort of get a sense of what the level of math is going to be in this class. Just make sure that this is all stuff you've seen before. I don't mean this as like these are 5 questions you have to be able to do right now. I would guess that less than half the class could just out of the blue do these 5 problems and get the right answer and stuff. But I want you to look at these questions, try to spend a little time trying to do them, make sure you kind of like sort of rings a bell, And if it doesn't ring a bell, you should come talk to me, and we should just make sure that this class is going to work out. I do think a lot of times if you don't have quite good enough math preparation, but you really need to take this class and you're highly motivated, working extra hard, coming to office hours a lot can make up for a lot of that, but we should talk about it if that's the issue. Okay, so here it is, math quiz. I'm going to write these 5 questions out, and then I'm going to stop and give you the rest of the time to fiddle around with these problems. And then I'll start the class on Wednesday going through how to do these problems, because you'll be dying of curiosity. And then the lab today for the people who are in section 91 is going to be really quick. It's going to take 20 minutes to a half an hour, I think, probably. And it's just a pretest for sort of your intuitive understanding of physics. We're going to do a post-test at the end. So obviously, most people here haven't taken physics before, so the average score is going to be fairly low, and there are going to be some questions where you don't even have a very good idea what they're talking about. That's fine. That's just how it's supposed to be. And then at the end, we'll do the post-test and see how much improvement people have made in this area. Okay, so the first question, first problem. Plot the function I equals x squared. I get these little, like every time I write, I get these little things I have to keep erasing because I'm left-handed, and my hand drags on the screen, and the world is not made for left-handed people. The second one, calculate the slope of the line between the points 1, 2, and 4, 3. So those are coordinates describing those points. Third, simplify the expression a times b squared times c squared divided by b to the 4th times a times the square root of c. Number 4, solve this expression for a, where a squared times b times c is equal to 4c plus b squared c squared. So in this one, you're not going to come up with a number for an answer. You're going to come up with an expression that has b's and c's in it. And then the last one, solve this system of equations. X1 plus X2 is equal to 50. That's the first equation, and then the second equation says 2x1 minus 3x2 is equal to negative 10. And this one you can find a numeric answer for x1 and a numeric answer for x2. So why don't you spend a little time seeing if you can work through those. If you need a little hint or something, I'd be happy to give you a hint, or you can, see if the person next to you knows what's going on. And that's it for class today. And so just meet me next door for lab, for the half of the class that has lab tonight when you're ready.